Hello everyone, in this video I am going to explain about electric potential due to a spherical charge distribution. This is very important question. You can expect this question in long answer. In this question we will see 3 points, that is when a point lies outside the shell, when a point lies on the shell and inside the shell. In this one, if you learn the outside the shell, then you can easily write the on the shell and inside the shell. So let's get into the answer. So consider a sphere. This sphere will conduct the charge. So with a center O and a radius of R, somewhere here consider a charge Q where the charge is distributed towards its surface area. Hence we can take the surface charge density sigma is equals to Q by 4 pi r square. Keep this as equation number 1. For this one, you need to take few points in this diagram. That is, our aim is to find the potential at an external point. So external point means outside point. Take this external point as P with a distance r from the center. It means that you need to take the distance from O to P as r. And for this purpose, we need to divide the sphere into number of rings. So for that one, consider one ring A, B, C and D. As I said, Q, which distributes the charge. You need to draw the diagram like this. Join CP marking it as X and COP as an angle with theta and AOC as another angle with d theta. I have written all the points here which I have considered from the diagram. Now from angle you need to take here E a point so that you can write OEC. From this triangle, take sin theta is equals to CE by OC, which is opposite by hypotenuse. So if you take this OC this side, you can write it as CE is equals to OC sin theta. That is CE is equals to OC means the radius R. So you can write it as R sin theta. From another sector AOC, AC equals to R d theta. So AOC is equals to AC equals to R d theta. Now we can write the circumference of the ring as 2 pi into r sin theta, and with circumference the area of the ring can be written as 2 pi r sin theta into r d theta. We got this area of the ring from the circumference of the ring with the sector r d theta. We need to find the charge. So the charge on the ring will be our 2 pi r square sin theta into sigma. If we do this one, we'll get 2 pi r square into sin theta d theta into this charge. As I said, this sigma is a charge. So if we substitute the sigma here, sigma value here, 2 pi r square sin theta d theta into this q by 4 pi r square here, we can write it as q sin theta into d theta by 2. Consider this is equation 2. Charge, so dq. I got this value by substituting 2 with the 2 and pi r square sin theta d theta. Therefore the potential V due to the charge dq is given by dv which is equals to 1 by 4 pi epsilon naught into dq by x. This equation number 3. You need to remember this one. So now substitute equation 2 in equation 3. We get dv equals to 1 by 4 pi epsilon naught into, in the place of dq we will write q sin theta d theta by 2 by x. If we substitute this one, we will get it as q sin theta d theta by 8 pi epsilon naught into x. That is, you need to take this x in reverse. I have written here clearly. So from this one I got this one. Consider this as equation number 4, that is dv. From this figure we can write x square is equals to r square plus small r square minus 2r cos theta. You can remember it as a minus b whole square. On differentiating with respect to x, so we can write it as 2x dx. These are constants, so it will become 0. Here we are having cos theta, so that we can write it as 2rr sin theta d theta. So if we take this one this side, sin theta d theta is equals to x dx by this r and r. This 2 will get cancelled. Here this is equation number 5. So by substituting this equation 5 in this equation 4 sin theta, then we can write it as, then dv is equals to q by 8 pi epsilon naught x into this sin theta and as x dx by rr. Here this x will get cancelled. Then we can write it as q dx by 8 pi epsilon naught into rr. Write this dx value separate as equation number 6. To obtain the potential due to the whole spherical shell, we need to integrate this equation 6 with by using these limits. So the limits are x equals to small r minus capital R and x equals to r plus r. So therefore v equals to limit r minus r plus r dv. So our dv value is this one. So r minus r plus r q by 8 by f naught into r dx. This value we can write it as v equals to, this whole thing is constant. If we take this side, q by 8 by epsilon naught into r. Here dx we can write it as x. So for this one we apply this r plus r minus r. So we can write it as q by 8 by epsilon naught into r plus r minus r plus r. So we can, this everything will get, so we get r cancel and the answer will be 1 by q by 8 by epsilon naught into r to r. This one and this one we can write it as 1 by 4 by epsilon naught into q by r. This is our equation number 7. With this one we will complete our 90% answer. Next, when point lies on the surface. Here this radius and the distance will be equal because the point will be lies on the surface. So r is equals to capital R. We will get it as V by 4 pi F0 into Q by R. This is equation number 8. Next we will have when point lies inside the cell. So in this case we need to take the limits reverse. These limits we will take it as x equals to capital R minus small r and x equals to capital R plus small r. So from equation 6 we get V equals to r plus r minus r, q by 8 by F0 into r. The same substitution we will get q by 8 by F0 into r x r plus r minus r, q by 8 by F0 into r. Here r plus r minus r plus r, q by 8 by F0 r into 2r. We get it as this cancel, 1 by 4 by F0 into q by capital R. This is equation 9. So the potential at internal point is same as the surface. Here ends our answer. If you go through again this answer, electric potential due to a spherical charge distribution. Here we are going to have a sphere. In this we need to take the rings A, B, C, D. From that one we get this circumference area and charge. You need to remember this dV, that is potential. From this one if you substitute further you will get this equations. When you get this equation, by seeing this you can write the second and third one. Here one more important thing is that first you need to take here x equals to small r minus capital R, that is this distance minus radius. So if you take distance minus radius you will get this one, and if you take radius minus distance then you will get like this answer. Don't get confused here, practice well. At last I will keep the papers. You can take the screenshot, and don't forget to like, share with your friends and subscribe my channel. Thank you.